Okay, this video is going to be recording about the 1.1 and 1.5 class notes that we took in class. So you can use it as a review, or if you were unable to attend class, this is your live version of it. If you have any questions, please contact me either through Canvas or my Polk email. Okay, so for this slide, what we want to consider is the difference between an expression and an equation. And as you can kind of guess from the English parts of this, equation kind of reminds you of equal sign. So part B here is the equation. Okay. And then for the second option, the expression, that is A, because as you can see, there is no equal sign. So the most we could do with A would be to combine our X values, but that's it. You're not going to find an answer necessarily for the expression from A, whereas the equation in B, we could actually solve. Okay. What you're doing here is you're just going to take a look at the definition for a linear equation in one variable. Your textbook likes to use this ax plus b equals 0. When I was learning intermediate algebra, college algebra, I was always taught ax plus b equals an unknown constant c, or a known constant c. So here, some folks might be a little bit confused as to why there's so many letters going on here, but A, B, and C are real numbers with A not being equal to 0. If A were 0, what would happen here is we would just have the statement B equals C, and that could be a true statement or that could be a false statement, and we'll talk about that a little bit later in the slides coming up. But the reason why I prefer to use the C instead of the 0 is I don't want you to think that all linear terms have to be equal to 0. Or sorry, not linear terms, linear equations. You don't have to have the 0. This C can be anything, which is why I make a note of it. So for anyone that doesn't watch this with the audio, let me just write here that C okay. Right? So the main two things to pull away from this is that A cannot be equal to 0 because otherwise we would not have a linear equation, and C can be anything, not just 0. Okay, so for this problem, what we're going to do is we're going to solve it. The first thing we're going to do is combine our like terms. So we're going to combine our X values, and conventionally, I like to combine them to the left. You'll see in section 1.5 when we discuss inequalities, there's actually a really great reason for getting into that habit of solving for the unknown on the left. It's not something that would cause you to lose points on an exam. That I would never do that. It's just conventionally solving the unknown to the left makes a good choice, and it's convention, meaning that most people do it that way. Again, not something that must happen. So I'm going to leave the 5x alone for the moment, and I'm going to work on the right-hand side. 2x minus 3x is going to give us a negative x. Okay, minus the 13. So basically, we only did one step there, and that's okay. You can do these as quickly or take as many steps as you need. It's what to each person's comfort zone. I know sometimes when I do these in person, I tend to go a little bit quicker because I'm just used to doing a lot of the steps. I do this a lot, so that's why. But I am going to try and take my time on the recording so you can all follow along with what I'm doing. So what I just did there is I took the negative x and I moved it to the other side. In order to do that, I have to add x to both sides. And now what I'm going to do is I'm going to get rid of the 11. So to do that, I have to subtract it on both sides. And I do apologize, when I have such a limited amount of colors, I apparently always go for Christmas. I'm trying to go for more Polk colors as well, but for whatever reason, Christmas tends to happen a little bit more often than not. Okay, so our answer here is x equals -4. You'll notice that a lot of the times I will box my answers and give it a check mark. So what that check mark symbolizes to me is that if I check this or chose to check it, which you should as often as you can, if we checked this and to check it, we would have to take -4 and plug it in for each of the x's. So we can actually do that real quick. Let's do 5 times -4 plus 11. And we need to see if that will be equal to 2 times -4 minus 13 minus 3 times -4. Okay, so here you're looking at 5 times the -4 will give us a -20 plus 11 will give us a -9. And then on the right-hand side, we have -8 minus 13 plus 12. Well, -13 plus 12 will give us a -1. -1 and the -8 give us a -9. So there we have it verified. Okay, so that is a very important objective for you guys. And although I'm not going to require it all of the time, don't be surprised if you don't see it on your test. Okay, I'm going to give folks a few seconds to write this down if you're interested. What you want to do for these is I always recommend writing down whatever you need personally. So if you can understand that A equals B, and then whatever you add to A and you also add it to B, then those are equivalent statements. The multiplication one is pretty similar. It's saying that, again, if A equals B, then A times something and B times that same thing. Again, those are going to be equivalent situations. Okay. If you need more time with this, you can always pause the video. Okay. So what we're going to work on here is we're going to worry about distribution. So what I'd like you to do is I'd like you to pause the video and I'd like you to work this out and tell me, or obviously you can't tell me, but what I want to know is to see if you get the same answer that I do. Okay, so hopefully you did as I suggested and you paused the video. So what you want to do first is you want to distribute, and I try to go ahead and do this on both sides. As if you need to do one step and then the other, you certainly may. But I like to try and combine those two steps. So your important part here that you need to worry about is if you see here, your 3 is a -3. You want to make sure that negative follows through in the distribution. So -3 times 2 will give you a -6. -3 times 6x will give you a -18x. 4 times x will give you a 4x. 4 times 1 will give you a 4. And then we're just going to bring down our 36. And now we're back to where we were before, where now we're going to combine like terms. So we have 2 here we can combine. We have 2 here we can combine. Here you can see I'm doing my Polk colors. And we have 2 x's that we can combine. So 2 minus 6 will give us a -4. And then I will take my time again and not do any extra steps. Just going to combine the constants. 4 plus 36 will give us a 40. Okay. And then what we're going to do now is we're going to switch our x's to the left and our constants to the right. So I'm going to add 4 to both sides, but I'm also going to subtract 4x. Okay. So these 4 cancels, the 4 x's cancel, and we're going to be left with 18 and 4 will give us negative 22x. And 4 and 40 will give us 44. We'll divide both sides by negative 22. And x is going to be equal to negative 2. Now, again, you can try to pause the video and go back to your original equation and check to see if our negative 2 is correct. You always want to go with your original equation, and here's why. As soon as we as mathematicians make a step, as soon as we go to do something, you don't know if you could have a mistake in there. Sometimes you could drop a sign, sometimes you could lose a variable. So you always want to go with your check with the original equation. So you kind of want to think about like keeping with the OG, right? So original equation, you don't want to go with this second step or, any other step. You always want to go with this original equation, and that's where you want to do your check. Okay, so for this problem, what we're looking at is fractions, and most people don't like fractions. So you can look at this a couple of different ways. You can either consider it as finding your lowest common multiple, so you can get rid of your denominators, or you can consider it finding your greatest common denominator. So basically, they're going to work out being the same. What we want to do here is we want to get rid of the denominator. This was actually a pretty cool question to do in class because we had a couple of different approaches. So I'm actually going to do this problem twice for you so you can see both approaches. So approach 1 is what I'm more used to, and you can kind of see here that 4 can go into 8, right? It goes into 8 twice. So what I chose to do initially, and this is how I saw it and how I was typically taught it, is I would multiply each piece by 8. And what happens here when you multiply by 8, I'm going to write it up here because you're going to see that we're going to have this statement twice, and that's going to show you like why we can do either method. So what happens here is the 8s cancel here, and then 4 goes into 8 twice. Okay, so what we're going to end up having is 2 times x minus 4 is what's left, plus the 8's canceled, so you just have 2x plus 4. And then 5 times 8 gives you 40. Okay, so that is a very valid approach, and it's the approach that I typically do. But let me show you now the approach that another couple of students came up with in 2 separate classes, completely independent of each other. It was pretty cool to watch. So what they saw is they said, okay, if I want to get both denominators to be the same, then I want to get them to be 8. In order for me to get 4 to be an 8, I have to multiply it by a 2. So when you multiply fractions, what you do to the top and what you do to the bottom has to be the same. That's how you keep that equivalency. So you can see that 2 over 2 would just be 1. So you're allowed to do that. So then what happens when you do this is you actually end up getting 2x minus 4 over 8 plus 2x plus 4 over 8 equals 5. And then for them, what they saw then is that, okay, I can bring these together. So then basically they had 2x minus 4 plus 2x plus 4 all over 8 equals 5. And then from there, what you can do is now you can multiply both sides by 8. Okay, and then that actually brings you right back here. Okay, the 8's cancel. You have 2x minus 4 plus 2x plus 4, again, equals 40. So, I mean, either approach, one is extreme, the second one is extremely elegant, really, because you're looking at it from a really great sense of numbers, and really kind of seeing that 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 you need those denominators to be the same. um, Both approaches, like I said, completely valid. I actually really like this one. I think it does kind of come with a couple of extra steps. But I mean, I really like it. So kudos to those two students who came up with that. Um, I'm not sure if they were taught that somewhere else, but I really think that's such an elegant process. I just like it a lot. Okay, so what we're going to do here is we're going to distribute. Okay, so we'll get 2x, and then 2 times the negative 4 is a negative 8, plus 2x plus 4 equals 40. So again, we're going to combine our like terms. Okay, so 2x and 2x will give us 4x. Minus 8 plus 4 will give me a minus 4 equals 40. We're going to add 4 to both sides. So 4x equals 44. We'll divide both sides by 4, and x is equal to 11. Okay. Again, you can choose to check it. This would probably be a good one for you guys to choose to check, because then it does work with those fractions, but I'm not requiring it. Okay, so again, I do have a couple of approaches for this one. I am only going to show you one approach, but your textbook, if you go into the ebook, you can find a similar example to this one, and you can kind of see how they do it. What they choose to do is they get rid of the decimal in like step 3 or 4, and I choose to get rid of the decimal right at the beginning. As you can see here, we go to the hundredths for all of the decimal places. So what we can actually do is we can multiply the whole thing by 100. And what I want you guys to notice is that when I multiply, you can see it back here as well. I guess more with the fractional example. Here, I just use the dots because I was doing top and bottom. But typically when I've gotten into the habit, and it's a good habit to get into when you're doing algebra, is you want to get rid of that habit of using the x as the multiplication sign, and you just want to use parentheses. They mean the same exact thing. It's just that right now we use an x as an unknown. So you can get really confused if you sit there and try to do x times x. Well, because for me, that's x squared. So yeah, there's a big difference with that now. Okay, so if we're going to multiply every piece by 100, then we would have 0.08 times 100 would give us 8x. And then 0.12 times 100 will give us minus 12 times x minus 4. And then 0.03 times 100 will be 3x minus 5. Now, the question we have to ask ourselves is, why did I choose to only multiply the numbers outside of the parentheses? Why didn't I multiply the numbers inside the parentheses? Well, the reason for that is because these are all one factor. Okay, so when we multiply the outside by 100, we're in essence multiplying that whole piece by 100. So we're not going to multiply it by 100 times 100. So we're not going to multiply or worry about the parentheses. All right, we're going to leave the parentheses alone and only worry about the outside term. Okay, so now let's go through and do our distribution. Okay, so we get 8x minus 12x plus 48 equals 3x minus 15. And then we're going to do our like terms again. So essentially just subtract 3x from this side, and then we'll subtract 48 to the right. So negative 12 plus 8 will give us a negative 4x. And we're going to add those together. So it's going to be negative 7x. This negative 4 is coming from that part there. Okay. And then negative 15 minus 48 is going to give us a negative 63. We're going to divide both sides by negative 7. So x is equal to 9. Again, I'm not going to require you guys to do a check with a decimal. I mean, granted, you'll have a scientific calculator, but I do like to make my exams where you wouldn't need a calculator at all. So I would not make you do this check, but you should be able to do it. Okay. So what I did in class is I decided to just talk about the definitions related to this section instead of having to go through and do each problem. But what I would like to do, since it's online and it's a review, I'm actually going to go ahead and do these ones for you. So at least to a certain extent where you can see what's going on. Okay, so let's go ahead and do this distribution on both sides, right? So we'll have 9x again, minus 3 times x is negative 3x, minus 3 times 4 is negative 12. And then we're going to have 6x, and 6 times negative 2 is negative 12. So here you can see when we combine this, we have 6x minus 12 equals 6x minus 12. If we finalize this, the 6x's cancel on both sides, and the 12s cancel. So that essentially means that we have 0 equals 0, and that's a true statement. Those are two separate words. Sorry, guys. So this is a true statement. Okay. So when we have a true statement, that means that we have what's called an identity equation. Okay, so essentially meaning no matter what you put into this x value, as long as you put the same value in each x, you're going to come up with a true statement. It does not matter how big the number is, doesn't matter how small the number is, if it's positive, if it's negative, as long as it's the same number. If you say let x equal 1,000,000, then you're going to end up with a true statement. That's it. Game over. So you have an identity. Anytime you have exactly equal statements, so 6x minus 12 equals 6x minus 12, those really what you're saying is that line is equal to that line. So all solutions are possible. So another way to say this is not just 0 equals 0 and true statement, but also all reals. And that symbol there stands for all real solutions. And later in the semester, you're going to see why I say the word real there. But I won't ruin the surprise for you. Okay, so let's worry about equation B now. So we're going to distribute again. So negative 3 times 2x will give us negative 6x. Negative 3 times 1, negative 1 will give us a positive 3. Minus 2x equals 3x. Okay, well, negative 6x minus 2x is going to give us a negative 8x plus 3. Oh, this is 3 plus x. This is why you always pay attention to what's going on. Okay, so I'm going to subtract 3 on both sides. They actually cancel on both sides, which is okay. And then I'm going to subtract x on both sides. So I'm going to get negative 9x equal to 0 and divide it by negative 9. That's a 9, not a g. So then x is actually equal to 0. Right? And that looks like your quote unquote normal equation. So what that tells you is we have something called a conditional equation. Conditional equation. And what this means is that when you have x equal to 0, you can only have x equal to 0. If you try to solve that problem and plug in and check with x equal to anything other than 0, it's literally a condition of that equation to be true. You have to use 0. If you use any other number, any other value, then you won't have a solution. It will not work. Your solution will be false because a condition of this equation is that you have x equal to 0, and that's it. Okay, so that's your difference there. So again, to recap, if you have a true statement, then you have an identity. If you have a quote unquote normal equation, then you have a conditional equation. So what's left, obviously, is going to be our C option, and that's going to be something called a contradiction. So you can probably guess what it's going to look like based on what we've already done. So we know that we'll have 10x minus 21. And if we do our distribution, we'll have 2x minus 10 plus 8x. 2x and 8x give us 10x again. I'm going to subtract 10x to the left. You can actually see they both cancel. So we're going to be left with negative 21 equals negative 10. That is a false statement. And because it's false, we call this a contradiction. Okay, so in absolute simplest terminology to help you remember, a true statement will be an identity. So think of it this way. If you are pulled over by the cops, they ask for your ID. You're not going to give them a fake ID. You're not going to give them your best friend's ID. You're going to give them your ID because that's your identity. You are giving them a true statement. You are who you say you are. So if it is a true statement, then it's an identity. If you have what I'm going to call a regular answer, then it's a condition. It's a condition of that equation to be true. So that's a conditional equation. And a contradiction is going to be a false statement. Okay. All right. Here you can take a moment and write down the steps for solving an equation. We basically went through this without saying it. So you want to clear out your parentheses, clear out any fractions or decimals, and then you want to combine like terms. And then what you want to do is you want to isolate the variable terms to one side and isolate the variable. So this is where we moved all the x's to the left, and then we got all the numbers to the right. And then the last thing you want to do is you want to check. Okay. So that is the end. This is the end of section 1.1, which I believe is titled Solving Linear Equations in One Variable. If you are someone who likes to do titles for your notes, this is where section 1.5 starts, and it is solving linear inequalities in one variable. And before I have you do the example with me, I want to make this a little bit bigger for you guys so you can see it real quick. what we're looking at here is linear inequalities in one variable. So you're going to have ax plus b and then some form of an inequality. And again, you don't have to always have 0 here. This can be any number. I don't know why your textbook likes to do that. I would use a C here because, again, it can be any number. It does not have to be 0. What cannot be 0 is your A. As soon as you were to get X to be gone, so in other words, 0x, then you no longer have a linear inequality. You just have a regular inequality that could be either true or false. Okay, so you want to have that X value present. All right. And if you need that a little bit longer, you can always just pause the video. All right, so let's get to work on this section. So what they want from us is they want us to write interval notation and to graph the inequality. So interval notation, before I go into answering these, I want you to take a look at the fact that the X is on the left-hand side. Because that X is on the left-hand side, we're going to be able to do a little bit of a cheat, a little bit of a trick. And that is, you're going to be able to look at this arrowhead, which is your inequality. But it's actually, if you pretend it's an arrowhead, it shoots towards the infinity sign that's going to be included. So it's actually going to be negative infinity, so parenthesis negative infinity, comma -1 parenthesis. Okay, so I'm going to write that again in case my penmanship was terrible. So this is a 1 and then another parenthesis. Okay, all right, if we were to draw this as a graph, when I only have one number, I like to give the opposite one as well. Now your textbook uses the parenthesis. So kind of like that, this is a parenthesis. I like to use an open circle. Okay, I'll use a closed circle for when it is included, and I'll use an open circle for when it's not. If you don't have an equal to part, it is excluded. So typically we use intervals when we're talking about something that has a range of options. So for instance, like sometimes in banking, you can have different flexible terms. So you can pay things off in 2 years, 3 years, 4 years, 5 years, whatever. So that would be a range. But let's say you can't go past 5 years. So you can't pay your item off in 5.5 years. So it has to stop at 5. So that would mean it would exclude 6. Okay. All right, let's look at B. B, the interval notation is going to be a bracket because do you see how there's an equal to part there? It's underneath. It looks like this. Well, that looks like a witch's nose. I apologize. Okay, it looks like that. This equal to part means we have to use a bracket. So it's going to be bracket -4, comma 2, and then there's no equal to part, so it'll be another parenthesis. And then if we were to draw that graph, it would be -4. Now we're going to have a closed circle. You can see the difference here. I'm really trying to shade it in. And then a 2, and we're going to do an open circle, and then anything in between. So the difference here, what this is telling us is that we could have -4, -3, -2, -1, 0, and 1. And then technically all the decimals and fractions in between as well, but you cannot have 2 and then anything outside of those 2 bounds. All right. If you have any questions on this stuff, or if you need to do a one-on-one Zoom with me, make sure that you get an appointment during my office hours. Okay, so this is having us talk about, again, that idea that if we add the same thing to both sides, then we'll have an equivalent option. And this is the same with any of the inequality signs. So basically, all this is really telling you is that you can treat an inequality sign for the purposes of solving like it's an equation, but then it just means different things at the end. So we're going to add 10 to both sides here. Okay, so what this means is instead of it being x equal to 3, it just means it's x greater than 3. So again, if we did the interval notation, it would start at 3 and go to positive infinity. And if we graphed it, it would be an open circle to positive infinity. Something I want you guys to pay attention to is that with infinities and negative infinities, you can't tell me what that really means. So you can't ever use a bracket with your infinity signs, okay? If you try to use a bracket with your infinity signs, you will get it wrong every time. So you have to use a parenthesis with your infinities. Okay. All right, so here we have minus x equal greater than or equal to -1. We're going to divide by -1. So what you're seeing here is when we divide or multiply by a negative number and we're dealing with inequalities, we're going to flip the inequality. Okay, so if we were to graph this, we're going to go solid circle because we have an equal to part, and then towards negative infinity. And then if we had to do the interval notation, it would be a bracket, negative infinity, parenthesis. Okay. All right, so for A, we're going to take 8x greater than or equal to -40. We're going to divide by 8. Now, here's your difference. We're not going to flip the sign because 8 is positive. Just because we have a negative result here doesn't mean that we need to flip the sign. All right. And then if we were to draw this, okay, closed circle because there's an equal to part with it, and then towards positive infinity, and then it would be -5 comma positive infinity, parenthesis. All right, B, we're going to divide both sides by -20. We're dividing by a -20, so then our sign is flipping. And then it would be 2 negative infinity, 3, 3, 0, -3, open circle to negative infinity. Okay. All right, here we're kind of going back to that same idea that we had before where we have to distribute. It's going to be the same thing that you guys have been doing, except now we're doing it with an inequality attached to it instead of an equal sign. That's really the only difference. We're still going to combine the same. So 5 plus 8 will give us a 13. I'm going to add 4x to the left. And for spacing, I'm also going to subtract 13 to the right. 13's cancel, 4x cancels. 4x minus 2x will give us 2x. 11 minus 13 will give me a -2. I'm not dividing by a negative number, so my inequality doesn't have to switch. And it's going to negative infinity from an inclusive -1. So I want to draw a closed circle. And obviously, you guys doing this not on a computer pen, yours would look much more cleaner and crisp than mine. Okay. All right, so let's get rid of these not parentheses sets. Let's get rid of these fractions before we continue. So what I'm going to do is I'm actually going to multiply by a number that all of these go into. 2, 5, and 4 all go into 20. So I'm going to multiply each piece by 20. Okay. When I do that, 4 goes into 20 5 times. So I'm really going to be multiplying this section by 5. 2 goes into 20 10 times. And 5 goes into 24 times. Okay, so we're going to get 5 times 3 here, and we'll do that in a second. 1 times 10 is just 10, greater than 4 times x minus 8. And then now we can get rid of some parentheses and stuff. So 5 times 3, I'm going to do this part off to the side so I can bring it down. So this little section, 5 times 3, will give us a 15. 15 goes here, so then we'll distribute. Okay, so 15x, and then minus, oh, that's a 2. Always double check your work. So minus 30 plus 10 greater than 4 times x is 4x. And then 4 times negative 8 will give us a negative 32. Negative 30 plus 10 will give us a negative 20. So we're actually going to add 20 on both sides. So 15x minus 20, 4x minus 32. So we're going to add 20 and subtract 4x at the same time, just because I'm running out of room. Bring it up here. 15x minus 4x will give us 11x. Negative 32 plus 20 will give us a negative 12. Again, we're not dividing or multiplying by a negative. We just have a negative in our answer. And then it wants us to graph it. So you're looking at a little bit more than 1. So it's going to be like right here, and it'll be open. As long as you're close, or if you label it, if you want to label it, instead of labeling it -1, you could label it, -12 over 11. It's close enough. Okay, so here's the differences here. You can notice that inside the two inequalities, well, first off, we have two inequalities, which hasn't happened before. And we also have things going on inside them. So what this is telling us is that, again, it's going to be kind of odd at first, but typically what we do with an equation is whatever we do to one side, we have to do to another side. When you have a complex inequality like this, you have to do it to all 3 sides. So that cancels that 2 out. And then you have 2 minus 1, which is 1, x, and then 3 plus 2, which is 5. We don't have to rearrange because 1 is less than 5, so that works fine. And then if we were to graph it, I would just do 1, 3, and 5. And again, open circle at the 1, open circle at the 5, and it's everything in between. Okay. If you really wanted to do the interval notation, it would be 1, comma, parenthesis, 1, comma, 5, parenthesis. All right, here we're going to add 5. And you guys can pause the video if I'm going too fast and you need a little bit of a break. I'm just trying to get through it all a little bit quicker at this point. So the 5s cancel. 5 minus 2 is 3. We have a negative 4x left. 5 and 7 give us a 12. And now you have to be careful because we're going to divide by a negative. So when we divide by a negative, we get negative 3/4. We have to flip this sign and flip this sign. And now what you can see is that the negative 3/4 is actually greater than the negative 3. So we're going to write this a little bit nicer. And when you change things around, you want to pay attention to the orientation with the X. Do you see here with this sign, it's opening towards the X. You want it to again open towards the X. That's what happens. And then here it opens away from the X. So again, you want to have it opening away from the X. That's what you have to do whenever you do that too. If you happen to solve for the variable on the right hand side and you want to use the trick, you have to always get it to the left hand side. So when you do that, you just keep the orientation of the sign with respect to the variable. Again, we can go over this either in an individual Zoom, or you can ask me during the test review and I'll go over that too. So that's these. And if you were to draw that, I think at this point you guys can draw that. Negative 3 will be on the left. Negative 3/4 will be closer to 0. I'll just do it in a different color so you can kind of know that it goes with this one. So negative 3 is going to be a closed circle. And then negative 3/4 will be an open circle, and it's going to be everything in between them. Okay. And then if you were to do the interval notation, it would be like that. Okay. All right, so we have 2 application problems. Again, if I went a little bit too fast on that last one, just pause the video and you'll be able to catch it all. So when you're dealing with an application problem, the first thing you want to do is you want to read the problem like you're a human being, and then you want to read it again as if you're a mathematician and figure out what you need to pull out. So a local health club charges $40 one-time enrollment fee plus $35 per month for a membership. Sarah can spend no more than $355 on this exercise expense. What is the maximum number of months that Sarah can belong to the club? So the first thing we want to do is a let statement. We're going to let X equal number of months. Okay. So the next thing we have to do is we have to figure out the numbers that we care about in like the key phrases. So $40 one time means we're going to have $40 once. There's no multiplier to that. But then it says plus, and so it literally tells you the word plus. So we're using an addition sign. $35 per month. Well, I said that X was my month. So it's going to be 35X. And then you would normally want to put an equal sign, but it says no more than. So that means that it has to be less than or equal to $355. So yeah. Sorry, guys. I'm a little bit dyslexic when it comes to my inequality signs, and that's no joke. Sorry, it needs to be this way. Less than, you make the L 355. So then to solve this, we're going to subtract 40 on both sides. So we'll get 35X. Keep your sign the same, and then this becomes 315. If we divide 35 on both sides, we get that X less than or equal to 9 months. Okay, which means that Sarah can only be in the club for 9 months. That means that anywhere between 1 month and 9 months she can belong, but she can't go over 9 months. So Sarah cannot be there for month 10. Okay, so the next problem, the last one actually for this set, is Joel has scores of 82, 97, and 93 on his first 3 exams for whatever course he's in. What score must he earn on the 4th exam to keep an average of at least 90? So at least 90 is important. And then he has scores 82, 97, and 93. And then we have an unknown 4th score. So to do this one, we would do 82 plus 97 plus 93 plus an unknown value. So you could say let X equal 4th test. Okay. And then since there's 4 tests to find an average, you divide by 4. And then it has to be 90 or above. Okay. So this part has to be at least 90, equal to 90, or above 90. So this side could be greater than 90. So if we add these together, 82, 97, and 93, we get 272 plus X divided by 4. So we're going to multiply both sides by 4. And that'll get rid of the 4 on the bottom. So it'll be 272 plus X. And then 90 times 4 gives you 360. We're going to subtract 272 on both sides. So then X is going to be greater than or equal to 88, which means that Joel has to have at least 88%. So I'm going to put it in the middle, at least 88%. And really, it would be on test 4. Okay. And again, you can pause this and write it all out. And then this just goes over the steps for solving a linear inequality. You want to clear away parentheses, clear fractions and decimals, combine like terms. And then I highly recommend that you get the variable on the left-hand side. They're agreeing. And that remember that you want to reverse the direction of the inequality symbol only when you multiply and divide or divide each side of the inequality by a negative number. Okay. If you have any questions, like I said, feel free to reach out to me. I can either do a one-on-one Zoom or I can try to cover it during the final, or not the final, but during the exam. If you're interested to know what objectives were covered, you can always take a look at my teacher notes. They're written out, and I will be posting those later in the, probably sometime next week. All right. I will see everyone in the chapter 2 video. Thanks for joining.